uniformly accelerated motion in one dimension. We know that acceleration is a vector, so an object in space with an acceleration a can be written in 3 dimensions as axi hat plus ayj hat plus azk hat. Therefore, along x direction only, ay will be 0, az will be 0, so that a will be just axi in x direction. Along y direction only, ax and az will be 0, so a will be ayj hat y direction. Along z direction only, a will be azk hat, and ax and ay will be 0, so z direction. Now let us consider an object moving from this point to this point z, but at a certain time t is equal to 0. You captured the distance to be x0 or x0 and the velocity to be v0. After a time t later, you observe that the displacement is now x minus x0 and the velocity is vx. Now means that vx minus v0 x along x direction over t minus t is equal to 0, t0, let's say 0, is equal to change in velocity over change in time, and is equal to acceleration. That means that vx minus v0 x is equal to ax times t minus 0, and vx is equal to v0 x plus ax t. So let's call this equation 1. For uniformly accelerated motion, velocity increases uniformly and the acceleration is constant, so throughout the duration of the time. So we assume that the average velocity will be equal to final velocity, which is vx plus v0 x all over 2. So we note this. Also, the displacement x will be the place you met it, x0. We don't know what it is. It can be 0. The place you met it times velocity times time. So we say that displacement x is equal to x0 plus average velocity times time, the average velocity with which is moving, times time. So it's equal to x0. You use this plus half vx plus v0 x, this times time, so that if we substitute vx, this equation 1 here, we'll have that x0 plus half v0 x plus axt plus v0 x times time. This is equal to this from here, from equation 1. So we have it to be x0 plus this is 2 v0 x over 2 is v0 x times t, plus this one is a times this is axt squared times half axt squared. Let's call this equation 2, and this equation 3 if you like, and this equation 4. We see from 1 that we can find t from here. From equation 1 above, we see that t is equal to vx minus v naught x all over ax. If we put it in equation 3, we'll have x is equal to x naught plus half vx plus v naught x. So we are putting for t vx minus v naught x over ax. So we have a difference of two squares. This times this, we have v x naught plus this times this is 2ax. So this times this is v x squared. This time this is minus vx v naught squared. This they will cancel. This time this minus v naught squared. If we do cross multiplication, you have x minus x naught times 2ax is equal to vx squared minus v naught x squared. V x squared is equal to v naught x squared plus 2ax x minus x naught. Let's call it equation 5. Equation 5. So if we put from all these equations now, if we say that our x naught from the diagram, if we say that our x naught is equal to 0 at t is equal to 0, it means that the displacement is just x minus 0 and it's x. The displacement is x after the time t minus 0 t, after the time t. So that means that the summary of the equations that we have obtained rectilinearly are v is equal to v naught plus at. We are dropping the subscripts. We are dropping x because this thing will hold in y direction. This one will be vy is equal to v naught y plus ayt. In z direction it will be vz is equal to v naught z plus azt. So we are dropping x, the subscript s. If we drop the subscript s, our equation 1 will become that. Our equation 2, this one will become, our equation 2 will become x is equal to 0 plus v t, that's average velocity times time. And our equation 3, if you like, our equation 4, this one, our equation 4 will become x is equal to v naught t plus half at squared. We are dropping the x conscript and this is 0, and the last equation, which is this, will become v squared is equal to v naught squared plus this. So our will be v squared is equal to v naught squared plus 2ax. So where x is our displacement, v is the initial velocity, v naught is the initial velocity, this is the final velocity. Thanks for watching.